Hey, we are live, it seems. So, hi everyone, good morning or good afternoon, depending where you are. Good night, maybe. I am Francois Scharf from the Data Chefs, and happy to be here to present today at the Knowledge Graph Forum, second presentation at the Knowledge Graph Forum. So this is exciting. And today I'm going to discuss enterprise intelligence applications in the private equity investment banking industry. I use these two terms, private equity, investment banking, a little interchangeably. There's certainly some differences to them, but you will hear that. So basically, this presentation will relate is the story of consulting engagement that we've had with the Data Chefs, where this firm came to us. Large investment banking firm came to us and asked us to help them with organizing their enterprise data as they wanted more agility in application development with their data. Before diving into what we did, we will see first present what is private equity and investment banking. What is that that they're doing, the customer, and what is enterprise intelligence in that context. And then we will describe three applications that we developed. One is an email alert application. Second one is a leads application for investment bankers. And the third one is a private enterprise social network for the bank. And all of that was built in parallel to building a knowledge graph that expanded as we added more data sources that gave us the possibility to build these more and more advanced applications as we went. Finally, I'll give some maybe a little more technical details about the knowledge graph and how we integrated it as well in the wider enterprise ecosystem. So there were two efforts, right? Like building the knowledge graph and expanding it in size, but also integrating it more with the enterprise information system. But first, a few words of the context. So we are the Data Chefs, open for work. We are a boutique consultancy. We're based in New York City, started in 2017, and we're specialized in enterprise data management. We have had clients in finance, legal, and technology domains, but we're open to work with others. We are a network of chefs, experts, consultants in our area with a large experience both in time and in skills. And we're especially focused on semantic technologies, knowledge graphs, ontology and taxonomy, data management in general, as you will see here today. And we provide a range of consulting services from hands-on ontology development, technical mentorship, proofs of concepts. We also are well-versed in machine learning, develop knowledge graphs, learn on them, do analytics on the graphs, etc. Our current focus is on studying the impact of LLMs on the ontology development lifecycle. This is research projects we're conducting. So the context, the private equity investment banking at a global scale. So our client is a bank with a few thousand bankers, right? So it's a fairly large investment banks. They have offices across 5 continents, and bankers are located in these different offices. Bankers are specialized either in a region or in an industry or a sector, right? So there are different kinds of specialty that can overlap sometimes. And their job is mainly tracking companies, right, to do financing, and we will come back on that. The main entity we have to work with is companies. There are wide estimate, 333 million companies worldwide, which is a lot of companies. And so tracking all of them is very difficult to do manually, hence the advantage of using data and automation in order to do that job. But let's dive a little bit deeper into what that job actually is, right? So in private equity, we're dealing with a world of private companies, right? opposite to public companies, which are companies that are listed on the stock exchange somewhere. When you're listed on the stock exchange, if you want to finance your company, you issue more stock, you sell stock on the exchange, on the marketplace, and you get money in return for this little share of your company, right? When you're a private company, you don't have access to that. So you have to go to see a banker and say, I need money to do X and Y. Will you lend me money? And so that's where the investment bankers are coming in, and they look if the project for that the company has is viable. What do they get in return? Is it worth it? Et cetera, et cetera. And they get paid by getting a percentage on the transaction, right? Maybe 3% of the transaction will go to the bankers. So if you imagine $100 million transaction, which is nothing big, like extraordinary, that's for one transaction, you're getting 3 million at the end. So it's quite a profitable job. Another scenario is companies getting acquired or getting sold, right? And companies acquiring other companies. So banks themselves acquire companies. They just buy these companies and they transform them, they sell them again, hopefully on a margin. But companies are also sold or bought regularly, right? So larger, like Google will buy a smaller startup, right? For example. And in every of these operations, you have investment bankers that are there and that come in and acquire, are helping with the process. So in this job, there are really two components. There's a social component, being there and knowing that a deal is going to happen, or facilitating a deal, like talking to a company, knowing that they want to be sold, and talking to another company that may be interested in buying, and then facilitating that transaction. So that's very social. That's calling friends and colleagues, playing golf with CEOs, these kind of activities. And the second aspect is number crushing. So you have to understand the finances for the companies. You have to build the deal, right? All this, like it's all financial, it's all Excel, and it's a lot of work that has to happen in a very short period of time. So here it is for the context. So really the main entity type in the investment banking domain is the company, right? It's all about studying companies, and the network of people around the company is also important. So we came in and we offer this vision of building a large enterprise knowledge graph from the company, which was at the time building a data lake. So it was on the process of building this enterprise data lake. And we came in at that point, and we jumped in on that process and did some added value through the knowledge graphs. So they have a lot of different data sources, both internal data sources. They buy also data through APIs, data sets that are regularly updated. Plenty of different software, SaaS software that generate data, that consume data. Your typical, fairly large enterprise information system. And they had started to put in place some processes around data quality, data governance, and MDM. But it was also interesting because we were also at that moment where these processes were still being set up. So we had an influence in that, how it will operate, and also interact with the knowledge graph. So we have a methodology. It is fairly simple in order to be flexible, but the general idea is to start small when doing a knowledge graph project. Because if you want to build the ideal knowledge graph in an enterprise, large information system, it is a tremendous amount of work, right? Like there are many, many data sources, there are many domains that need to be integrated. The work of building these integrations, developing the ontology is large, and what you can always maybe find someone, an executive that will sign this $1 million check over several years, and that will commit to it, but this is a rare thing. Usually projects are progressive and step by step. So you need to start small and show value very quickly. So the first project should be an end user application. When you're building your knowledge graph, you're not delivering a small knowledge graph, you're delivering an end user application that makes use of the knowledge graph. Once you have success there, you've shown that you're able to develop something useful, then you scale, you expand the knowledge graph, you expand the knowledge, the domain, and you quickly prove that as you do that expansion, it becomes easier to develop application, to have new wins for the graph, as you add data sources to this existing knowledge graph. So you prove that the cost of developing new application is lower and is lower as you expand the graph. And once you have these 1, 2, 3 smaller applications, then you go for the bigger one, more ambitious projects. At that stage, you should have reached a fairly large maturity level for your graph. So this is what we did, and the first project we undertook was an email alerts project. So back to the context of the investment banker. So they want to follow companies, and it's a job where regularly they need to check the news and get in touch with the executives at the company to say, hey, I've seen you're doing this, maybe you would be interested in my services for that, right? So here we designed an alerting system that would, based on some interesting news that around companies, would, alert the banker and give them the opportunity to send an email to an executive at the company, right? So in input, we had a banker companies of interest that would watch news being added to the knowledge graph, and in return, in output, send an alert to the banker with an email template. So they would just have to personalize it and click and to send an email to get in touch with the client or potential client. So that could be something like they have a new chief financial officer, or they've raised like large startup, go Series C, round of funding, etc. So important news, not worthy news there. So for this, we plugged an internal database of the clients and bankers' interest together with the news, company news that we plugged from a service. We integrated those in the knowledge graph and then built all the pipelines around this in order to develop that system. So I mentioned the companies the bankers follow, company news. We had to develop an ontology to represent that, companies, persons, news events. And we build the data integrations and pipelines to the knowledge graph to ingest this data in the knowledge graph, all the mapping infrastructure to match the different the data sources to get entities in different data sources, and generated this alerting system in output. So that was a win. They were happy with it, and now they started to come with other requests. And the second request was more investigative. So there are companies that I follow, but there are also companies that I don't know about. And so if you're a certain banker working in a geographical sector or working in a specific industry domain, you always are on the lookout for new companies in that domain. And so they would come up with a few criteria depending on their job and their role and their domain, and saying, okay, here are my criteria. Can you find relevant companies for me? And these criteria would evolve, would change across bankers, etc. So that was the second project, was to do this. So here is an example of criteria for an IT banker, right? Specialized in IT. So country in the United States, information technology is the industry sector for the companies. They have different types of financing statuses that they're interested for the companies, ownership statuses. So basically they're interested in all sorts of private companies that are of a certain size, etc. Some more detailed, complex, financially related criteria that they have. And so combine all that, right, was the set of criteria that they wanted to find companies for. So what we did is we added more data to the existing knowledge graph. So we had this internal database that was already a good source. The news were still there, and we added like a large vendor, like private companies database, right, from that we would get from a vendor. So that we integrated to the knowledge graph. And here's, you see on the right, this is an example of a Sparkle query that translates these criteria basically in Sparkle, right? And so we could run these queries either on demand. We developed this app. So there's this app where they can select the criteria or change some criteria, right? Like, so they can vary the status, the industry, depending on what they're interested in. So, yeah. And so that was basically it. Now, what we realized then was we could also take this and add it to the email alert system, right? And so instead of being just alerts based on the company they follows, we can also have alerts based on their criteria. So if the CEO changes at a company that they don't necessarily follow, but is according to their criteria, right, then they would get an alert and would be able to then send an email to the CEO. So great, they were very excited about that. But then the problem became, well, if I don't know the company, how will I send an email to the CEO if I'm not in touch with them? How is this going to work? And usually the way they do that is they call their friends, walk to the office next door and ask, do you know this company? Do you know someone who worked there? They use LinkedIn. Oh, I see my picture has turned somehow. This is weird. Okay. Hi. It's a little weird. Anyways, so what they needed there, so until now it was basically like using tools, manually talking to people, calling others, sending an email, hey, do you know someone there? Oh, I've seen X is working there, and that kind of process. And so they asked us if we could build something more automated on that, such as an enterprise social network on top of that. So that was the larger project we did, as it required to significantly scale the knowledge graph to several billion triples. And we added more data sources. We had interaction models. So when you build this type of network, so the network there is fairly simple, right? It is people and companies, and especially executives who work and have roles at companies, their history of their work, right? So they used to work in other places, and then plugging on that all the bank social networks, so all the bankers and their relationships with the people in that global companies network. So we built some models that would measure the relationship strength in order to be able to calculate, what are the warmest paths from one person to the other. So bankers X wants to get in touch with CEO of company Y. What is the shortest path? What is the warmest path in order to be able to reach that person? And so the knowledge graph there, it required quite some infrastructure in order to scale. We developed an application, both like a mobile application and a desktop application that will allow you to search for a person and then get contacted to that person, like see the shortest path to reach out to that person. But also that infrastructure then became in place, and we could use the data in the previous applications in order to recommend how to get in touch with the person based on an alert or a criteria search. So that's basically it for the applications. I mentioned we also got integrated in the enterprise ecosystem. So as we did all that process, the knowledge graph found its place on top of the data lake, right? So we would consume the good quality data, but we would also perform our own quality analysis on the data and report that back to the data quality team. So that was this this nice loop happening. Data governance, we integrated with the data governance software so that the terms, concepts, and properties in the ontologies were connected to the data sources to which we had written these mappings to the knowledge graph. So all was governed into the, is governed, I don't know why I used the past there, is governed according to the data governance policies that are in place. Same with the master data management, right? We helped with the knowledge graph because we did a lot of data integration in the knowledge graph that helped to build this list that were that are then maintained in the MDM software. And then we built several access points in order for data science team to access the data and consume it, both through APIs, but also we plug that to Databricks that is used quite a lot in the company. So the graph data could be processed to write models and train models. We use Protégé for the ontology. We use Pool Party for the taxonomy. We built a very large industry taxonomy, or very comprehensive industry taxonomy. And the graph scaled to a few to several billion triples. We scaled it on a cluster of Allegro graph DBs, and we computed, we had quite some computations happening for the social network in order not to have to actually ask Sparkle queries every time a user would tap on an app, but having some pre-computations of path in shortcuts in the graph. And we built all these data ingestion pipelines and provided APIs. I mentioned that. So thank you for your attention. We're here to help, open for projects, and thank you. If you have questions, we're here. I'm not sure how questions are working. Oh, I see the chat. Question from Theodora. Hey. The social component you mentioned, what was your major challenge during that tacit knowledge into formal descriptions? What was your approach to capture that particular type of knowledge? Right. So I think that application had two challenges. One was the scale, right? So the scale of both the data, but also the usage of this data was a step up. So we had to do work on optimization, going to a cluster, pre-computing some of the path, etc. But I think your question really is on the on how to extract the tacit knowledge of people knowing each other or not. So luckily we had access to emails, and so in emails you can extract the metadata network of emails, which is what we did, and so we built a model, machine learning. We use machine learning to build a model of how warm is a relationship between two persons based on the patterns of email communication. You know, how often and how old or how recent they are, and that works pretty well. We also use some software that does this. There's something like a specialized investment banking software called IntroHive that helps also with this kind of things. And then then that was pretty that was the kind of tacit knowledge we used. The rest was really explicitly, you know, included, like the roles, who worked when and where. Bob wants to know about what we did with Pool Party compared with what we use Protégé for. Yes, so we started with Protégé, and which was okay for the ontology development. But for the taxonomy and managing the taxonomy, we built a whole industry coverage set of taxonomies for each industry. And that was a large project involving a lot of time put, and basically, pool party gave us more agility, more convenience in development. So that's what it gave us. Protege is a clumsy piece of software. I'm not actually sure it's even maintained anymore now, but I think yeah. the space is ripe for a new open source ontology development software. If you want my take on this. Hossein has two questions. What was your strategy for prioritizing the sources, the external ones, to incorporate into the knowledge graph? So that's a great question. The question of prioritizing the source here, and this is part of our methodology, right? It really is related to the application. What is your application? What are we trying to achieve? What is the service we want to provide to the client? And so then you start there, and then you walk back to the data. Identifying the data sources. So we have, we do interviews in order to achieve that, identifying, what are the data elements, where do we find these data elements, and what data sources are the relevant ones, and then we add them like this. So we really follow the application. And two is, the alert system is, it's purely rule-based. The alert system we did for worthy news, it purely uses Sparkle. Naso, hi Naso, how did you deal with the KG governance in this project? How were you managing updates from external data sources? So we had cron, so regularly. I think I mentioned MuleSoft. MuleSoft is data pipelines software that allows you to run jobs that import, ingest data every now and then into the data. We have developed our own identifier mapping system that tracks where are the data sources taken from, what are the identifiers, what is the core identifier for a special entity. So this was a pretty cool. I mean, this is still in use. Pretty cool technology. So. Which is basically a large table in Databricks, very large table mapping identifiers to the different identifiers in the different sources. So for the entity matching, what did we do? I think most of it we managed to do through identifiers. And email address being one identifier, right? So for people, we had this email was, a good identifier, and we did some matching as well. We used some matching software. We had a data quality team that, did some manual validation. So classical entity matching, record linkage process there. Thank you all. If you have any other question, I think there's 1 minute, but otherwise, thanks.